welcome to the Roads weekly webinar. Today's topic is going to be extending your application using native extensions. And so what this involves is we're going to actually write some native C code and Objective-C code for the iPhone platform today. So to start off, we'll generate our application. We'll just call this one Accel. So some of you might know already, accelerometer support is not supported currently in the Roads platform. However, on the iPhone you can get the accelerometer data. So the native extension today we're going to implement is something that can read the accelerometer. So we created our application. We're going to create a model as well. We'll just call the model the same thing and give it arbitrary attributes because we're not going to be using it for that. Okay, so we have our application here. So to start using native extensions, we need to make a folder called extensions, and that's where our extensions is going to reside. We're going to call our extension Accelerometer. So we're going to create a new folder here. And we'll add a Ruby file to that here. Accelerometer.rb. So if you wanted to do pure Ruby extensions, you would simply add all of your Ruby code into this accelerometer folder, and in the build.yaml you can now specify your extension accelerometer. So at build time, what this does is it picks up the accelerometer folder, takes everything in your accelerometer folder and puts it into your application. And so then you can simply do a require accelerometer and it will load this accelerometer.rb file. Since we're focusing on native extensions today, we're not going to be doing any Ruby code here. We're going to need to create a folder called ext, which is where you put your binary extensions. So we'll create a new folder here. And we also need to add a configuration file for our extension called ext.yaml. In ext.yaml there is only two entries. The first will be the entry point into your C extension. So this is a C function that takes no parameters and returns no parameters, and it's used just to start your extension in, initialize it, and integrate it into the Ruby code. We also need to add libraries that need to be linked. So we're going to have accelerometer is going to be the name of our library. So the name here in iPhone and Android, your extension name is going to be output lib accelerometer.a, or whatever you have in this field. For Windows Mobile, you would have accelerometer.lib. So the next step is to start preparing our build scripts. So we'll create a new file here, and we'll call this one build. This is what gets executed to compile your extension. For Windows, you would have build rake.bat. We're actually going to be using rake to compile our extensions, so we'll go ahead and create a rake file as well. Your rake file needs to be called by your build scripts. So in the script build, this is going to be a Unix script. So we'll just have it run rake. When your build scripts run, they will be called from the main roads build script, and it will simply load your extension.yaml to determine what the parameters for it is, and then it will call build. So if you don't want to use rake, you can put all of your compiling commands here. If you want to use any other tool, the only requirement is that you have a file named build and that it is executable. We can put the same thing in our build.bat, but since we're not doing it for Windows Mobile, this isn't going to matter. So once we've done that, it is basically ready to build native code. So we'll go to our wiki page here, and there are some environment variables that are passed into this build script that allow you to get the paths to the different routes and information about the platform that is being built. On the wiki page, native extensions, there's a section here that lists all of the environment variables that get set when your build script is run. So target tempter is where your output needs to be put. So your extension, in this case it'll be lib_accelerometer.a, needs to be placed into target tempter when it is completed. The platform, row platform, is whatever mobile platform that the user has typed to build. For example, if you did rake run iPhone, your platform would be iPhone. And it has the possible values are iPhone, Android, and WM for Windows Mobile. Currently, BlackBerry does not support native extensions. Row root is defined, which it points to the root installation folder of the roads framework tree. If you install this as a gem, it points to where the gem is installed. If you're working from source code, this is put in the source code. Temp files dir is simply a temporary path that gets cleaned up. Any temporary targets that you use, you can put in here. Android NDK is if you're doing an Android build, it will give you a path to the NDK being used. And Android API level will give you the API level that is being used for the build as well. If you're building for Windows Mobile, VC build is set, and VC build will be placed to the VC build application. So if you have a Microsoft project file, you'd point your VC build. Your VC build would be used to build your project file. If you're doing an iPhone, you have a platform developer bin-dir, which it points to the bin-dir of the current platform that you're building. Typically this will be the iPhone 4 SDK, either for the simulator or for the actual device. SDK root is where the root SDK of the simulator is used. Again, this is similar to the bin-dir. It will have whatever the current build that you're doing. And ARCS gives you the architecture being built. On iPhone, if you're building for the simulator, it'll be i386, and it'll be ARM v6, ARM v7 for iPhone. So those are the important environment variables that you need to use when you're doing native extensions. So let's go ahead and start writing code for our accelerometer. This is going to be in Objective-C. So we'll create our header file here. In our header file, we will use UIKit, which is where the accelerometer library is for iPhone. We'll define our class here. The documentation on how to access the accelerometer can be found on the iPhone developer portal. So for our header file here, we're going to simply have a class named Excel. It's going to implement the UI view controller delegate, and we're going to have one method called start. We now will create our matching.m file, and we'll call this excel.m. We'll have some global variables to store the acceleration values as they're being read, and a reference to our Objective-C object. Because Roads is written in C and the Ruby implementation is in C, you have to expose a C interface to any Objective-C code that you do. So we're going to use this variable to store our instance of the accelerometer class that we just created, and then write a couple of C functions that accesses this and will return the readings to our Ruby code. So let's write our implementation of the accelerometer class. So we'll have our start method here, and we'll initialize our variables. We're going to set the update interval for the accelerometer. And we're going to set the delegate to this class. So on the iPhone, what happens is you set an update interval, and then the accelerometer will call you back by setting yourself as the delegate to the delegate method, which is what we're going to implement now. And again, how to use this is documented on the iPhone developer portal. So that's all the code needed from Objective-C to actually read the accelerometer. We now need to implement a couple of C functions that we can use to interface with our Objective-C. So we're going to make sure we can only start this once. Going to initialize our accelerometer class here and start reading. We also need to be able to get our readings from our accelerometer. So we're going to implement a function here that will return readings to our Ruby code. So that's our Objective-C implementation of our accelerometer. To get the accelerometer input into our actual Ruby code, we need to have Ruby functions and create a Ruby object and have basically our Ruby functions available to the Ruby VM in the Ruby specific way. So the way we're going to do that, we could write it by hand, except that is pretty tedious and it's very repetitive work. So what we're going to do is we're going to use a tool called Swig, which basically wraps C code for various languages, and Ruby is one of the languages that it implements. So for Swig, you need to provide it with an interface file. So we'll create our new interface file. We'll call this accelerometer.i, which is the same name as our extension. And that's the class that Swig will create when it creates the Ruby code. If you name this something else, then that would be the class that is created. So in our accelerometer.i file, we're going to define the module name. We're going to call it accelerometer. And then we provide it with the function definitions that we have just created using the Objective-C code. So we're going to have one for get readings, and our start function. And then we have to tell Swig how to return these values. Start is easy because it is simply takes no parameters and returns no parameters. Get readings is a little bit different. Because get readings returns values through pointers, you have to tell Swig that these are going to be output parameters and not input parameters. Because it doesn't know what you're thinking, and in C, it can be interpreted in many ways. You can be passing things by reference, or you can be passing references to be filled in by the function. Since that's going to be our case, we're going to have get readings here, and then we will call this with the output keyword. What this tells Swig is that these are going to be output functions, and so it will return all of these in an array. So when I call getReadings method, I will get an array of 3 doubles, which Swig then converts to the Ruby equivalent. So now that we have our code ready, we need to go to our build script. Since we'll be using rake, we're going to start with namespace build, and then we'll have a config task, and then we'll have an all task, and we're going to call a method build extension Accelerometer, and we'll also pass it in the architecture that we're going to do. And then we're going to say our default task is build all. And then we'll have our function here build extension, and we'll also require file utils. So what we have here is the basic framework of building an extension. In our config file, our config task, we're going to verify that we get all the proper parameters, and then check for specific platforms and set things up for our build. So we'll have target dir, and we'll call this target temp dir. And then we'll raise an exception if it doesn't exist. We'll check our temp dir. And we'll do another raise here. We'll just do some copy and paste. We'll also get our root dir. Have an error message for that. And so finally we're going to check the platform and do some configuration for specific platforms. So for example, if we're doing Android, we would have if row platform it's Android, we'll do something. Else, if env row platform is iPhone, this is where we're going to set up things for iPhone. So this is how you check between different platforms and do different platform specific build stuff. You get passed in what platform you're doing, and you can do specific setup based on if it's Android, Windows, or iPhone. Since we're only looking at iPhone right now, we're just going to do the iPhone stuff. And so we're going to now check all of the iPhone specific variables and set them accordingly. So to avoid typing all this in, I have an example I've done already. And we'll just stick that in here. We check the platform bin.dir and set that. We check our SDK root, set that. Check our architecture and set that. And then finally we give paths to GCC and AR, which will create the library. Once that's all completed, we can go to the actual compiling. So we'll set this up here. And then we'll set our tempter. We'll do some clean here. So basically any object files we will remove. And we'll do the same thing for any .a files. And finally, when Swig generates our interface file, it will call it the name of our .i underscore wrap.c. So we'll remove that just to make sure if we make changes to our interface file that it will be regenerated when it is built. So now we're going to use Swig and process our files. So we have our interface files here. And then we'll put the command that we're running in case we need some debug. And then finally we will use backticks and execute our file here. So what this does is it's going to generate all of our files, all of our .i files. It's going to not generate our .i files, sorry. It's going to iterate through all of our .i files and generate the C files that match that. So next we're going to compile the C files. And we use glob here to get all of our C files. I'm going to go ahead and copy and paste some code that I've already written for this. So we'll take a look and see what this code does. First, we'll get a name for our object file. So basically we're just going to replace .c with .o and add that to a list of objects because we need to keep that list for when we go to link them later. Then we're going to start building up arguments for our C compiler. So we're going to include current folder. Platform shared Ruby includes our Ruby libraries. This is the header files for our Ruby distribution that's in roads. And any shared files are located here as well. And root.dir is what the environment variable row root is passed. And so these are common to all platforms. If our platform is Android, we're not going to do anything because we're focusing on iPhone today. If our platform's iPhone, we want to grab the iPhone specific Ruby files, set some flags for Xcode. IsysRoot sets the root SDK of where the GCC compiler will pick up the libraries such as the UIKit libraries. Set our architecture, set our optimization level, give it the object name and the file, build up our command, and execute it. So this will compile all of our C files. Next, we're going to compile all of our Objective-C files. And so I'm going to copy and paste another snippet here. These files here is very similar to the .c. Because it's only iPhone, all we have to do is check for iPhone, go through all the .m files and add them to our list of objects, and then add the specific flags that are needed for building for iPhone. So there's all these options here that aren't really documented anywhere. When I went to go implement this the first time, I had to go and run it from Xcode and see what flags it's passing to the C compiler when it's compiling the .m files for the different platforms. So once I did that, I simply copied the different settings in here and then applied the specific architecture, the system root, object name, and the file name. The whole format of this file is based on the digest extension, which is located in the Roads SDK in the extensions folder. And you can use that for an example of how to build for the various platforms, because the digest extension has the different compile settings for Android, Windows Mobile, and iPhone. And so that will give you a good starting point of building your own scripts. The code for this also is going to be checked into GitHub into our webinar sample project.